Okay, welcome everyone to choose. We are starting a new unit today. I posted a test for the last unit on the blog. When you have time, you can look at the test, submit it. A few people have submitted their work already, and try to get that marked today. I am going to be taking it maybe even more slowly than I was before. We'll gauge how the class is doing. Remember, for your schedule and your other responsibilities and everything else you have going on in your life, so you can only work to the best of your ability. We're going to start the new unit, geometry. We do have, just so you know, I'll just put the outline up as well. So I've kind of done a rough, I don't know if you can see my notes here, but we're on geometry. It looks like we're sort of halfway through. These last few, though, are quite short compared to the first three. Home and vehicle finance were very large units, so it was nice that we got those done basically when we were still in school. Trig was fairly large too, but now you'll see that they chapters get very condensed. They're much shorter, which is nice, right? Because as we ease off, it's very difficult learning from home. So it's nice that we have the smaller chapters. It doesn't necessarily mean that the content is super easy, but because the chapters are shorter, it's just easier to get a handle on the whole unit, right? The unit isn't large, so that lets you understand the concepts maybe a little better because there aren't as many concepts to have to wade through. So there's only 2 lessons in geometry: quadrilaterals and regular polygons. So the word polygon just means many. Poly means many sides. Quadrilaterals are 4-sided shapes. So maybe I'll do that first. And that's what we're going to spend quite a few days on. These are 4-sided shapes. And that word quad, the prefix quad, means 4. So if you had quadruplets, you would have had 4 babies. Anything with a quad, when they talk about quad, like a quad is a four-wheeler, kind of like a electric motorcycle-ish, but it's got 4 wheels. And when people refer to a quad, like they're going to walk to the quad, it just means like a 4-sided courtyard or a 4-sided field. And polygons, the word poly means many, and this means shapes with many sides. And that means the sides don't have to be 4-sided. We actually just finished studying a whole unit on 3-sided shapes, right? Trigonometry was 3-sided shapes. Now we'll talk about 4-sided shapes in lesson 1. And then lesson 2, we talk about all other kinds of shapes. So of course, we know there can be shapes with 5 sides, 6, 7, 8. An 8-sided shape is an octagon. Okay. So we start lesson 1, and as I said on the blog before class started, I'm going to only do a couple of pages because there's so much reading to do that it takes a long time to absorb the content. So I'm going to start talking about quadrilaterals and their characteristics. Part of your job is to separate out in your mind the different quadrilaterals and the different properties that each quadrilateral has. Well, first of all, the quad, that prefix means 4. So quadrilaterals are 4-sided enclosed shapes. By enclosed, it means there's no holes in the edges, right? They're enclosed. There's no little opening. So quadrilaterals are 4-sided shapes. And remember, even though this unit is very dense, in a regular school setting, you always would have had notes that you could refer to and formula sheets, right? So you don't have to memorize any of this. And for today's, or I guess for this course until the end of June, you'll always have your notes in front of you anyway, right? Just because that's how this year is playing out. So certain quadrilaterals have special names and characteristics. Each type of quadrilateral has different properties based on the lengths of their sides, if the sides are parallel, the lengths of diagonals. And a diagonal is a line that stretches from corner to corner. We'll talk more about those in a minute. Angles formed at intersections of diagonals, bisection of diagonals, size of interior angles. Okay, this is important to note. When we took all of our notes about trigonometry and we were studying trigonometry, we learned that the angles of any triangle always add up to 180 degrees. So there's a similar, okay, so that's interesting to know. Now we're going to talk a little more about what an interior angle and consecutive interior as below. Work with your teacher to fill in the required information for each quadrilateral. So this is one type of quadrilateral, right? A rectangle, which you're probably familiar with, a square, a kite, sided shapes. I'm only going to do the first 2 pages today, okay? Just because there's a lot of info to talk about. So the first shape we're going to talk about is the parallelogram. And just like when we talked about when we were talking about triangles, and do you remember when we talked about an equilateral triangle, all sides were the same, or an isosceles, 2 sides were the same system? So when you see, if I go to this third one, if I see there's a notch here and a notch here, that means these 2 sides are the same, okay? If I have a double notch and a double notch, that means these 2 sides are the same. Now, it doesn't mean double notch and single notch aren't the same. So these 2 sides aren't equal. Opposite sides are equal. Opposite sides are equal, okay? By the same system, by the same definition, sort of, if I have a double notch angles would be equal to each other. Single notch angles would be equal to each other. And this is known as a diagonal, okay? This is a diagonal, and this is a diagonal, okay? You can see that the diagonals themselves are different sizes. So I'm just going to kind of draw a little arrow here. This is one diagonal. Okay, so this one, and this one is another diagonal. A 4-sided shape would have 2 diagonals. Just because it only has 4 corners, right? 4-sided shape create 4 corners. And if a diagonal is the line that connects corner to corner, these aren't, like this would be a line connecting corner to corner, but this is side, right? So diagonals run through the middle of the shape and connect corners to corners. So you can see that the diagonals themselves meet in the middle and they cut each other in half, right? This diagonal cuts this diagonal in 2 equal parts. And the second diagonal cuts the first diagonal in 2 equal parts. And I know that because double notch, single notch, single notch. So those were what all our symbols mean. So this is indicating these 2 angles are equal and these 2 are equal. These are diagonals and they both cut each other in half. And then this notching system means same length. And this is something new. This little arrow will be something new. These little arrows mean that these 2 sides are parallel, and the double arrows mean parallelity as well. These 2 sides are parallel, okay? So the arrows, I don't know how I'm going to do this. These arrows mean that the sides are parallel to each other. And parallel means that two lines or these notches mean angles are equal to each other. And we already knew about the notching on the sides. We knew that from our previous trigonometry units. I'm not going to bother reiterating that. Hopefully you remember that. So knowing everything you know about a parallelogram and with parallel sides, right? Side lengths are any sides congruent. This is a new word. Congruent means equal. So yes, in a parallelogram, the opposite sides that are opposite to each other are equal to each other. Okay, so we say opposite sides are congruent. Okay, the same. Are any sides parallel? Yes, these arrows mean these two opposite sides are parallel. Perpendicular sides. Are any sides perpendicular? So that word perpendicular means meeting at a right angle. Okay. We talked about that in right angle trigonometry, which was more discussed in the grade 11 course. But so I'm just gonna remember that means meets. And I look back here, none of these degree angle, well, not in this parallelogram. No. There are no angles. Are the diagonals congruent? And remember, congruent means equal. Now, this diagonal does not equal this diagonal. You can even visually see, because the parallel is tilted, or the parallelogram is tilted, that one diagonal will be quite a bit longer than the other one. This is the long, this is the short. So are the two diagonals, is this diagonal equal to this diagonal? No. One diagonal is longer than the other. Are the diagonals perpendicular? Okay. Well, let's see. The diagonals are crossing here. Do they meet at a 90 degree? It doesn't look like it, and there's no box. No. There is no 90 degree angle where they cross. Now, if there was a 90 degree angle, there would be a little, remember those little boxes? It would be like a little box like this. They would put a 90 degree in here, but they didn't put one, so that means there is no 90 degree angle, okay? Do the diagonals bisect each other? That means where they meet, do they cut each other in half? And yes, they do. They cut each other in half. That word bisect means cut into two equal parts. So they do, right? This diagonal cuts this one in perfect half, and this diagonal cuts this one in a perfect half. Angle sizes. Are any angles of equal size? Well, let's go back to where they talked about angles in the first picture. These two angles are equal. These two angles were equal. So they're opposite each other. So I guess we'd say some very similar to what we said up here. Opposite angles are, I could say equal or congruent, but I'll say equal or equal. Oops. I was going to say equal size like they did, and I screwed up my printing. Okay. So that's a parallelogram. It's a four-sided shape that looks like it's been tilted. It's leaning to one side. It's got some interesting characteristics. These are all the characteristics that they share, and you're supposed to remember all that. But remember, when you're doing an assignment or a hand-in, you'll have your notes in front of you, so you could just refer to your notes if I ever asked you about a parallelogram. The last paragraph on page 1 says, parallelogram has several shapes that are also considered special parallelograms, but they get their own names. A rhombus, a rectangle, a square. And I think we're really familiar with rectangles and squares. And now we're going to look at special parallelograms. So that's something interesting to know that that these three shapes are part of the family of parallel. So let's flip the page. I'm just going to do one more page of notes today because I've already been talking for 20 minutes. And I know there's lots to talk about. So we're just going to talk about, now again, remember, so this is the confusing part, I think, in some ways, that the rhombus, the rectangle, and the square, and maybe I'll finish talking after the square, but you can see that these are all types of parallelograms, right? I've got the rhombus, the rectangle, and then the square would be parallelogram number 3. So rhombus, rectangle, square. So let's take a look at the rhombus. Now the rhombus doesn't really look different if we just flip back for a moment from the one we were just talking about, right? This looks kind of similar. So what's the difference between just a regular parallelogram and a rhombus? Well, if you noticed something, the rhombus is a special type of parallelogram with all sides equal. So I'm just going to state that right now. A rhombus is a parallelogram with all sides equal. Okay, so let's just run through our list of definitions. Side lengths, are any sides congruent? All sides are congruent. And from the page previous, remember congruent means equal. Are sides parallel? Well, let's look. It doesn't say it here, but this is a parallelogram. That means this side and this side are parallel. The only thing that's different is that the sides are equal length, but really opposite sides are still parallel. That's what makes it a parallelogram. So are any sides parallel? Opposite sides are parallel. Are any sides perpendicular? Now I see, are any sides perpendicular? Well, here's side 1, 2, 3, 4. There are no right angle corners. No sides are perpendicular. There are no 90-degree corners. That's the only, if two sides meet at a 90-degree angle, you'd get a 90-degree corner, so no 90-degree corners. Are the diagonals congruent? Again, no, and I can visually see this. This one, because the parallelogram is tilted, there's always going to be one long parallelogram and one short one. They do bisect each other, I can see, but for them to be congruent, I would have to have like a double hash. These two would also have to be double hash, but I can see this diagonal. These two hash marks don't equal triple hash marks. So like double hash marks don't equal triple hash marks. So the diagonals themselves are congruent. So I would say no, one diagonal, they're not congruent. One diagonal is longer than the other. So when your parallelogram is tilted in the classic shape, you'll see that just even visually, you can see that kind of quite clearly that this diagonal will be far longer than this one. Are the diagonals perpendicular? Well, yes, they are, right? This is a 90-degree. So this indicates, maybe I'll go over here. This indicates 90 degrees, 90-degree symbol. And 90 degrees means perpendicular. Are the diagonals perpendicular? Yes. They meet at 90 degrees. Okay. Do the diagonals bisect each other? No. Or pardon me. Sorry. Yes, they do. They're not the same size. I'm sorry. But they do bisect each other because they cut each other in half equally, right? This long diagonal cuts the short one in half, and the short diagonal cuts the long one in half. So yes, they each cut each other in half. That's what bisect means. They each cut each other in half. Angle sizes. Are any angles of equal size? Well, same rule would apply. Opposite angles, they're not all the same. I can see that these are two obtuse angles, right? Larger than 90 degrees. These are smaller ones. So angles of each equal size. Yeah, that goes back to the definition of a parallelogram. Opposite angles are equal. So this angle equals this one, and this angle equals this one. Special parallelogram number 2. So this shares all the characteristics of a regular parallelogram except all 4 sides are equal. And special parallelogram number 2, this is something we're probably quite familiar, one of the shapes we're most familiar with. It's a rectangle. So you already know probably a lot about a rectangle. Opposite sides are equal. It's not tilted, so parallelograms don't necessarily have to be tilted. Because this one is not tilted, I can see the 90-degree corners, right? What else do I see? Just before I'm even asked any questions. Opposite sides are equal. Opposite sides are also parallelogram. Themselves are equal to each other. And the other question we're always asked is, do the diagonals meet at 90 degrees? And they don't. So let's see what we can answer here. Side lengths. Are any sides congruent, equal? Yes. Opposite sides equal. Are any sides parallel? Yes, opposite sides are parallel. Right? And if I wanted to, I could show that just with this one arrow means parallelity, and then these guys would be parallel too. Yes, opposite sides are parallel. Are any sides perpendicular? Yes, the sides meet at 90 degrees. And that's what perpendicular means, right? 90 degrees. So every corner is 90 degrees. Are the diagonals congruent? Are they the same length? Yes. The diagonals are the same length. Are the diagonals perpendicular? No. Once again, if they were perpendicular, we would see that little box, right? They would meet at a 90 degrees, and we'd have to put the box in. So no, they do not meet at 90-degree angles. Angles are created, but these aren't 90 degrees. You can see this one's obtuse, greater than 90, and this one's little, less than 90. Do the diagonals bisect each other? Yes, they do. They each cut each other in half. Angle sizes are any angles of equal size. All of the corner angles these angles, corner angles, are 90 degrees. Okay, so they all equal each other. Okay, I've been talking quite a bit. So I think what I'm going to do is, I suppose what I could do, tomorrow I'm going to have a work period. And I'm going to just give you a little bit of time to maybe start a few of the questions. So let's finish up the square parallelogram, just to finish off parallelograms. Not much new to see here, right? This is special parallelogram number 3, and it's the square, probably really familiar. What do we know about the square? Equal, 90-degree corners. Diagonals are equal to each other, and they cut each other in half. Really, the only difference between a square and a rectangle is in a square, all sides are equal. And because all sides are equal, the corners meet at 90 degrees. So whenever you have equal sides, the diagonals are going to be 90 degree, right? We saw this in a square and a rhombus too, right? All sides are equal, so they meet at 90 degrees. Side lengths, are any sides congruent? All sides are congruent, equal. Are any sides parallel? Yep. Opposite sides are parallel. Are any sides perpendicular? Yes, sides are perpendicular to each other. Those little boxes mean the sides meet at 90 degrees. Are the diagonals congruent? Yes. They are the same size. Are the diagonals perpendicular? Yes. They meet at 90 degrees. Do they bisect each other? Yep, they cut each other in two, right? Are any angles of equal size? Yeah, just like the rectangle, all corner angles. As a matter of fact, all of the corner angles and the interior angles and where the diagonals meet. So all the corner angles are 90 degrees and all the angles created where the diagonals meet are 90 degrees. So that was a lot of info today, right? Just a lot of sort of note-taking, a lot of definitions, new words. So all I'd like you to do tonight, if you have any time at all, and I'll maybe give you a bit more direction tomorrow, just go back and look at all the new vocabulary that we talked about, right? The word congruent is probably new. The word bisect, we already knew perpendicular. Parallel might have been new for you. Diagonal might have been new. And then just all the words like rhombus, square, rectangle, I hope you knew already, but probably not parallelogram. So just go back and look at your notes. And like I say, I'm going to intersperse work periods with live stream. So I'm going to end it today. And have a good evening, and I'll see you tomorrow.